our third year of university, we took a lot of the principles that we learnt in our first and second year and applied them to some more difficult problems. If you haven't seen those videos already, they'll be linked down below in the description. This year, we learned algorithms and data structures. A lot of working as a software engineer requires you to recognize patterns in problem solving and understand what's available in your knowledge arsenal to apply it to your solution. It's a bit like expanding your vocabulary. If you want to learn more words, you need to expose yourself to different words in different contexts to understand when best to use those words. The same thing can be said for learning algorithms and data structures. You need to learn what algorithms and data structures you have available to you so you can understand which one best solves your problem. Algorithms can be broken down into two categories, sorting and searching. They're pretty self-explanatory. Sorting algorithms take in a list of data and order them according to a specified criteria. For integers, this can be from lowest to highest or ascending. And for strings, this could be alphabetically. Some popular sorting algorithms that we learnt were bubble sort, merge sort, and quick sort. Searching algorithms take in an item and search a list for that item. Some popular searching algorithms that we learnt were linear search and binary search. Now let's get into data structures, which are different tools you can use to organize the data that your application will be using. There are several data structures you can learn. In our degree, we covered arrays, linked lists, stacks, queues, trees, heaps, and hash tables. An array in Java is a linear list of data, which is built into the language. Linked lists are similar to arrays, but each item in a linked list has a pointer to the next item. If you had a doubly linked list, each item would also have a pointer to the previous item. Stacks and queues in computer science work like how they do IRL. Stacks follow a LIFO pattern, like a stack of coins. The last coin you put on the stack will be the first coin you remove from the stack. Queues follow a FIFO pattern, like a queue of podcasts playing. The first podcast in the queue is the first to be played and removed. We have videos on these data structures linked in the description. Trees are different from the data structures we've seen so far. Trees are not linear, they're hierarchical. They're used a lot in AI development to provide an efficient storage mechanism for problem solving. Heaps are similar to trees, but the tree is a complete binary tree. There are two kinds of heaps, min heaps and max heaps. Max heaps ensure that the largest value is at the top, and min heaps ensure that the smallest value is at the top. Lastly, we have hash tables, also called dictionaries. These are data structures that have key value pairs. They're super useful because you can retrieve data from them quicker than with lists. Our third year was possibly our most important year because it prepared us for interviews as professional software engineers. The key takeaway here is that the principles of computer science are language agnostic, which means you can apply them to any programming language. You can write a merge sort for a linked list in any language. The main thing that interviewers are looking for is your problem solving skills. If you want to learn about how we tackle interview problems, drop a comment below. This brings us to the end of our computer science degree in a nutshell. We wanted to give you an overview of what we learnt in university to help you make decisions about going to uni or being self-taught. If you enjoyed this video, don't forget to drop us a like and subscribe. Catch you in the next one.